Hey everybody, Dr. Jensen with CCJ 3701 Research Methods in Criminology. So hopefully by now you've started to think about the kind of information your variables have and whether that's, nominal, ordinal, interval, or ratio. Okay. That's why I was banging into your head so much whenever we would work on labs or coding or we would do lessons on it. It really does matter because if you know how stuff is measured and you know what's in your data, you're going to know what to run. That's it. That's all you need to know because each little statistical test you learn has certain requirements of the kind of data it can analyze. So you just have to know what kind of data it requires. So we're going to be doing a lot more on that so you feel more comfortable making those decisions because otherwise this class starts to feel like, okay, I know how to recode. Okay, I know how to do a summation and a scale. I don't know when I'm going to use it, when to use it, how to use it, what it's all for, and you start feeling kind of lost at sea with this stuff. Like, how is all this going to come together and how do I get from here to there? That is going to be coming, but in the meantime, we're going to start to get some of these sections drafted so your paper starts emerging out of the darkness. But this will come together. It'll start to have that light bulb moment that you've been waiting for. You kind of have to trust me on this. It will happen. All these things are done for a certain reason, for the kind of learning that we need you to accomplish so you can kind of sequentially make those steps to the final product. So you're getting there. Don't worry. If you're feeling a little lost or a little confused, you're probably not alone. It's okay. I'm here to reassure you and tell you you're probably on the right track. You learn the skills, you know how to do stuff, you're going to be fine. So this video is writing the hypotheses. So I would encourage you, if you haven't watched the video on which regression should I run, you need to watch that first because you need to make that decision first. Otherwise, this video is not going to be as useful to you. So you need to pause and watch that and then come back to this. All right, so by this time you should know whether you're running a linear regression or a logistic regression depending on the kind of information in your dependent variable, nominal, ordinal, interval, or ratio. Okay. For the linear regression, you can kind of craft these in a lot of ways, and you can look at journal articles and the sample paper for more examples. But this is the rule of thumb. So for linear regressions, if you know you're running a linear, you're going to use words like relationship or increase or decrease or having positive or negative relationships when you write hypotheses. So here are the examples. This one is looking at the lab assignment that we recently did, attitude toward abortion and education. So we always have a null and an alternative hypothesis. So we assume that these things aren't related. That's the null. Nothing is here. It never works. The alternative is there really is one, that these two things actually predict each other and they relate to each other to help us know how this works. Okay, so we always have the null and the alternative. We call that the research hypothesis. It's the main one we're trying to test. Are these things related and how are they related? So the null is there is a linear relationship between education and a person's attitude toward abortion. The alternative is there is not a linear relationship between education and a person's attitude toward abortion. So basically it's just kind of flip sides of the same thing. There is a relationship, there is not one. That's it. Very easy to write. Moving on, you're going to make predictions about some other variables that you're going to run. So these are just a few different ways to write those. You can kind of describe them using different language so you don't get too bored. Hypothesis 1, you're going to write 3 more besides just that null and alternative hypothesis. So you're going to write the null, the alternative, and then 3 more. So you'll have a total of 5. Okay. Hypothesis 1, this is on one of the control variables in this study. Individuals who have been pregnant will have a lower score on the abortion scale. Remember, all a hypothesis is a prediction. This is what I think is going to happen in specific details when I go to run the test or I go to do the stats on the variable. You're just making a specific prediction about the things you're observing and measuring. That's it. Whether you're right or wrong doesn't matter. Welcome to science, okay? In science, we make predictions. Sometimes we're right, sometimes we're wrong. So don't worry about getting it just right. You're just making a prediction. You don't have to know what happens. Hypothesis 2, Democrats will have a higher score on the abortion scale as compared to Republicans. That's just another variable. They're looking at political party and making a prediction as to how they think that's going to work out. The predictions always have to do with performance on the dependent variable. So you're predicting how the independent variable is going to perform on the dependent. So you're always writing in terms of the dependent, because the dependent is what happens, right? It's the outcome, it's the result. Do we think the result's going to be different for different groups, or it's going to be higher or lower? Those are the things you write about. Hypothesis 3, respondents who do not have health insurance will have an increased score on the abortion scale as compared to those who do have health insurance. Or you could say they have a higher score. You could write language higher or lower, increase, decrease. So you're just making predictions about what you think you're going to find before you run all the analyses. And then you get to find out if you're right. And like I said, it's okay to be wrong. It happens all the time in research, and it's really not that big of a deal. Okay, so that's for linear. Second part is for logistic. How do you write hypotheses for logistic regression? Again, you can look at journal articles that use this technique and certainly the sample paper to get some ideas. Okay, so for binary logistic regressions, you're going to use words like likelihood, chances, or odds of something happening. Okay, so here's some more examples. This one has to do with depression and drug use. Okay, we kind of talked about these examples too. So the null hypothesis, the odds of a person being diagnosed with depression and choosing to use illegal drugs will equal 0, meaning these two things don't predict each other. They don't have any likelihood with each other. The alternative hypothesis, the odds of a person being diagnosed with depression and choosing to use legal drugs will not equal 0. It'll be predictable, right? We'll have a chances or a likelihood of something happening, and if it equals 0, it means there really is no relationship. If it doesn't equal 0, it means there is a relationship, and these things actually influence the likelihood of it happening. Okay? So again, that's our null and alternative for logistic regression, also called the research hypothesis. So you're going to write that plus 3 more, just like you did in linear. Okay? Now for your paper, you're really only running one regression. Make sure I make that clear. You're not running both. You're just running one. That's it. Okay? You're either do linear or you're going to do logistic, and that's going to be the big chunk that is your results section of your paper. And you're going to write about all the statistics you find and what everything means in English. You're going to make a really cool table that I show you how to build to display all your results. And that's basically going to be the main part of your results section, which we're going to be doing in the following 2 weeks. Okay? Here are the last 3 hypotheses. Hypothesis 1, respondents from urban environments will be more likely to use illegal drugs. So they're going to have a control variable called like urban versus rural. Hypothesis 2, respondents who are low income will be more likely to use illegal drugs. Okay? And hypothesis 3, respondents who completed a college degree will be less likely to use illegal drugs. So again, you can make whatever prediction you want as long as you make the prediction. Okay? And you're going to see if you're right. So realize we talked mostly about the dependent variable, how that is measured. That's because we're trying to predict the variance in it and predict how it's going to land, and whether knowing something about you is going to let us predict the thing that happens to you. So the thing that happens to you, we have to know how that's going to all lay out, and how suitable the statistic is for measuring and calculating that. So it's all been dependent variable, dependent variable. We haven't talked a lot about independent variables or control variables. So as I round off this video, independent variables can be measured however you want. Linear regression and logistic regression, because they're multivariate techniques, you can literally load like 40 variables in there and nobody will care. You can do unlimited numbers of analyses with unlimited numbers of variables. The independent variables and control variables can be measured however you want. So they can be nominal, they can be ordinal, they can be interval or ratio, categories, quantities. We have different ways of interpreting different kinds of variables, but they can be anything, okay? It's just the dependent variable that's going to direct kind of what technique we need to do to analyze it. But the independent can be measured however you want it to be. Some people are like, well, I really like this variable in SPSS. It actually is the way I want it. Do I have to recode it? If it's interval, you might not have to. You could probably leave it as it is and analyze it out of the box, ready to go. You wouldn't have to code it or change anything to it. You just stick it right in the equation as its original variable, the way it's listed. And I encourage people to do that. If you have a really good control variable or independent variable that is a quantity, it's interval, I would hesitate to recode it unless it really doesn't satisfy your need for what you want to know. The reason I wouldn't recode it is, again, interval and ratio style variables have the most measurable information inside them because they can quantify things, and we love quantities in statistics because we can make exact predictions and know exact amounts of things going on, and we like that exactness. Ordinal and nominal style variables are different because they kind of group things together and you lose a little bit of that information and that exactness when you do that. So again, if you want to change interval variables that are independent, you want to only do that if it doesn't satisfy your need of how you want to measure things. But other than that, they can be measured however you want. So that's the end of the video. Hopefully you found this helpful. Sorry, that's family in the background. And we'll see you later.